Question 3 is about the manufacture of ethine gas, and we've been told here the equation for the reaction and the enthalpy change, which will come in handy later on. First task is to find an expression for Kc. Now Kc is always a ratio of concentrations, and so we can write the concentration, and it's always products divided by reactants, so we've got the products here. We don't need to put the state symbols in because it's clear which substance we mean because they're all different. And then we remember that we raise them to the power of their stoichiometric coefficient. So in this case, our expression for Kc is going to look like this. Now that's going to come in handy for the next part of the question, so I'll just keep that there as we look at the next part of the question here, which is this research chemist investigating how to improve the synthesis of ethine from methane. And there's some key information we're told here. So 4 decimeter cube container, and that's going to give us the volume of our system. And they heat the container and allow equilibrium to reach a constant temperature, which is good because if it's not constant temperature, then Kc is changing and we've got a problem. Total gas volume does not change, so we've got this as our volume. Now the equilibrium mixture contains this many moles of CH4 and this many moles of C2H2. Now what we have to do is calculate the number of moles of H2 in the equilibrium mixture. Now it's really important in these questions that we have the equation very, very close to hand, so I'm just going to rewrite it here because this is going to give us all that key information. So what we need to do is work out what has actually happened. So we can do this in a table here where we've got the start and the equilibrium. And we don't actually know how much methane that we started with, but we know that at equilibrium we've got 9.36 times 10 to the minus 2 moles. So these are amounts in mole. And we know that as 0.168 moles of ethine has been formed, and because we know we only started with CH4, we know that that has been formed by the CH4. Now, because of the stoichiometries of the reaction, if this many moles of ethine have been formed, then 3 times as many moles of hydrogen have to be formed, which gives us 3 times 0.168, which is 0.504 moles. And now we've got all these quantities at equilibrium, so we can go on to calculate the equilibrium constant in this case. But what we must remember is our expression for the equilibrium constant is in terms of concentrations. So we must first find the concentrations of each of these substances. Now that turns out to be relatively straightforward because we've been given the volume of the container already in decimeters cubed, so we just need to do 0.168 divided by 4, which is going to give us 4.2 times 10 to the minus 2 moles per decimeter cubed. If we want to now work out the concentration of hydrogen, we need 0.504 divided by 4, which is in that case 0.126 moles per decimeter cubed. And the final one is to work out the concentration of methane, which again is the same volume of container, and that turns out to be 2.34 times 10 to the minus 2 moles per decimeter to the minus 3. So if we then put these into the expression for Kc, we simply need to make sure that we raise them to the appropriate powers, and then we need to plug these numbers into a calculator. And the beautiful thing with modern calculators is that you can simply type that in just as you see it there, and you will work out from that that the value of Kc is 0.153 in this case. Now I've got to work out the units of Kc here, and it's useful to come back to our expression for Kc that we had up here. So in terms of units Kc, we write in what the units are for each one. So this is mole decimeters to the minus 3. We've got hydrogen cubed, so that's going to be moles cubed decimeters to the minus 9. And then on the bottom here we're going to have moles squared decimeters to the minus 6. And so we can do some cancelling here. If we say that mole here is going to cancel with mole there, another mole there is going to cancel there. So we've already got moles squared coming out of this. decimetre to the minus 3 is going to cancel with those to give decimetres to the minus 3, which is going to cancel with 3 of these decimetres to the minus 3 to give decimetre to the minus 6, which gives me overall a units of moles squared decimetres to the minus 6.